Hello. Today I came across a way to do mathematical division, and my daughter presented this problem to me, and she said, I can't understand how this is done. And I took this screenshot from a computer program which is used to teach mathematics to the students here in Norway, in Asker. And I must say that this is a horrible way to teach. So, what are the problems with this way of solving this kind of division problem? This doesn't show the student that what is being done, how it's being done, how do we reach certain conclusions. So that is the problem with this way of solving division problems. So in this very question, it is 81.6 being divided by 2.4, and the result is 34. So what's being done here is that the instructor says that, okay, what we do is first we multiply both sides by 10 to get a whole number on each side to remove the decimal mark. That is okay. But then the instructor says, well, you know what, we are going to take out 480 out of this 816 because that is what is fully divisible by the number 24. And the argument here is, my argument is that how on earth would a student know that out of this big number the student has to take out a certain number? And how on earth would the student know that what all are the multiples of this number 24 here? The students hardly know the tables until table of 8, hardly. Most of the students don't know the numerical tables. And then to expect that they would know that 24 multiplied by some x number would give us some new number. So this is the problem with this way of teaching the division especially. So I'm going to show you two methods. Actually, it's the same method. One is the longer working and the other is shorter working. But it will show you what is being done so you know how to handle this. Right. So,
we want to underscore.
Stupid. Right. Let's come back to this. Okay, so I'm going to show you the working of how to actually solve this in an easier to understand way. It will show you all the working so the student understands, can build a map in his or her head that how to solve this and how it's done. So let's go to that. Here I have a graph sheet, sort of. So let me write this question again. So the question is 81.6 divided by, first I write it in Norwegian way. So 81,6 divided by 2,4. I don't understand that why there's a difference of standards in mathematical notations in Norway and the rest of the world, and it causes a great problem when the students go to higher classes and they go abroad, and then they have to switch their mindset between the comma and the decimal, and it has potential of bigger mistakes. Anyhow, so this is 81,6 divided by 22,4, which is actually in In the rest of the world, it would be translated as 81.6 divided by 2.4. Right. So to simplify this, what we can do is we can start with the operation which would remove the decimal. So to remove the decimal, what do? We see that both numbers have only single digit decimal, right? On the right side. So I'm going to write a number just for the sake of example. If you have a number 2.5 and you multiply it by 10, now what you get is 25. Why is that? Because when you multiply any number with 1 and x amount of zeros, the decimal will move to the right side x amount of zeros. So here we see 1 0 in 10. So the decimal will move 1 point to the right. That means this will eventually become 25 point. But since mathematically we can't write 25 points, so we write 25.0. And since 25.0, this is insignificant, so we simply write it as 25, right? So this is a refresher. I'll just do one more example. If I do 2.5 multiplied by 100, so now this, we see that we have 2 zeros here. That means the number, whatever it is, the decimal will move 2 points or 2 places to the right, like so. So this means this can be written as 2, 5, and the decimal has moved 2 places, but we did not have a place here. You see, this is empty. So what we are going to do is we are going to fill it up with a 0, and we'll just say point. So 22.5 multiplied by 100 is 250 point. Since we can't write it like this, so we will use the notation 250.0. And since mathematically this is insignificant, we can just ignore it and consider it 250. So this was the refresher on decimal movement. So now we see that both of these numbers here, 81.6 and 2.4, both have only single digit decimal on the right. So what we can do is we can multiply both sides by 10. And I'm using international symbols, which should be easier to understand. You feel free to convert it to a dot, this multiplication sign. All right. So, and then we multiply 2.4 by 10 also, both sides. So this would eventually result into this decimal moving 1 point, 1 position to the right, right? This is what's going to happen. So this means that I'm going to write it as 816 because the decimal has moved to the right. And if you look at this example here, this is eventually what it looks like. So I've just, since I've already shown you this step, so I'm just going to skip that, just write 816, and this is going to be divided by, and then this 2.4 will become 24 because the decimal has moved 1 point to the right. So this was one step which was skipped, or many students don't know, but now you know. Now you have 816 divided by 24, and I'm not going to show you this example. This had, where is that? This one. So we are not going to do it like this. We are going to do it easier way. So now we have 816 divided by 24. Now anything divided by anything else is basically reduction, right? If we divide 4 by 2, it basically becomes 4 by 2, which basically becomes 2 ones are 2 and 2 twos are 4, so it becomes 2 in short. So it has reduced by the same divisor, right? So what we are going to do here, we are going to check what is the last character here on both numbers, this one and this one. This is going to help us reduce these two numbers. How? Because we are going to find a divisor, a number which divides both of these numbers fully. So I'm going to see if both of these numbers are even numbers. That means these two numbers can be easily divided by 2, both of them. So they will reduce. If it had a 5 or a 0 at the end, then I would divide both of them by 5. And so on. You probably know or don't know about all these tips. But for this exercise, let's limit ourselves to seeing or verifying if both these last characters or last digits are even numbers. So that means they are divisible by 2. So that is what we are going to do. Just like we multiplied both sides by 10 all by ourselves, we had a liberty to do that. So we have a liberty to divide both sides as well with the same number. So we are going to divide both sides by 2, and I'm going to write it like this: 816 divided by 2, and this whole thing is divided by 24 divided by 2. Alright, so now we can solve both sides independently. Right, so 816, you know that if you write 9 divided by 3, how do you solve it? You basically put 9 inside this special symbol, put 3 outside and say 3 3s are 9 and nothing is left. That is the way internationally division is done. And this is the very basic way of dividing numbers. So I'm going to do the same, and this is just to show you the process. So I'm going to divide 816 by 2 here. And I'm just going to keep repeating this division sign until I reach a point where I have to actually solve it. Right now what we are doing is we are solving left hand side and right hand side of the division sign, not the equal sign. So I'm going to write 24 and I'm going to write 2 here because 24 here is being divided by 2. Alright, so you can solve either of them first, but we have to go we have to take both numbers together in one level or in one step. So 24 divided by 2 will work like this. 2 one time is 2, and then you put a cross out sign here because 2 minus 2 is nothing, is 0, and then you bring down 4, and then you say 2 multiplied by 2 is 4, right? And then you minus that, subtract that, and you get nothing here because 4 minus 4 is 0. So your answer to this particular subdivision is 12. Right, so let me write 12 here. Now we solve this 816. So 2 2s are 4. 2 2s are 4. No, sorry. We know that 8 is a multiple of 2. So 2 4s are 8. 2 4s are 8. And then you subtract them. 8 minus 8, nothing left. So you get 1 here, the next number. Out of this 816, you get 1. But this 1 is smaller than the divisor here. So there is no way that 2 can divide 1. So what we are going to do is we need to bring down this next number as well, but we can't just bring it down. We are going to say that we need a placeholder or a new or a accommodator, so to speak, and then we say bring down 6 as well. So now we have 16, which can be divided by 2 because 2 8s are 16. So we write 2 8s are, or 8 times are 16. When we subtract them, we get nothing left. So that means our answer to this division is 408, right? Right. Let's move down a little. Right. Now what we have is, let me rewrite this clearly. We have 408 divided by 12. So we have successfully reduced some large numbers to a smaller number. They have to be divided by the same number. Alright. Now I see, I apply the same principle again and I see and I check, are the last digits of both numbers divisible by a common number or by the same number, some number. So I start with 2 and I immediately see that both of these last digits can be divided by 2. That means I can divide both sides by 2 again. That way it will be reduced. So that is exactly what I'm going to do. I'm going to say 408. I'm going to multiply it by, not multiply, I'm going to divide it by 2. And this division 12 divided by 2, right? Both sides divided by the same number. We have the liberty and luxury to do that. Right, so we repeat the same process. We keep this division sign here because we are just transferring it in each step, and we do this division. We have 12 and we have 2 as the divisor, and we have 408 and we have 2 outside, which is the divisor. So now let's solve each side. So 2 in by what multiple 2 gives 12? So 2 6 times is 12. So we immediately found our answer to this division. 12 minus 12, nothing left. That means this is a full division. And we have 6 as the answer for this division. Now we go back to this division here and we start dividing it. 2 2s are 4, right? We subtract these 2 and we get nothing here, and then we bring down 0, but there's no way we can divide that, right? So what we do is we need another number, so we put a 0 here, always a 0, and we bring down this 8 here. This makes it 8, not 80. So this is just 8, right? And we know that 2 4 times is 8. So we write 2 4s are 8. And we do a subtraction here as well. 8 minus 8 is 0 or nothing left. We have a successful full division. This one. So now we have the result. Let me rewrite it here for you. So this becomes 204 divided by 6. Very good. Okay. So now we can continue. We see that both of these numbers, I'm going to verify it again and check it again. Both of these numbers have the last digits which are even numbers. So that means I can divide them by 2, right? So let's do that. So 204 divided by 2, and we bring down this division, 6 divided by 2. We have divided both sides by 2. Let's do the operation again. So this is 6 inside, 2 outside. 2 3 times is 6. We know that. Subtract, we get nothing else. So we have successful operation and we get 3 as the answer to this side. Right. And then let's bring down this division here. And then on the left side we have 204 divided by 2. Let's solve that. So 2 ones are 2, right? We do a subtraction. 2 minus 2 is 0, which is, I would say, nothing left. And then I bring down 0, which is not enough, and I need another number. So I just write 0 here. It's always going to be 0 on the top. And then I bring down this 4 here. So we know this is just 4, not 40. So we know 2 2s are 4. So we write 2 multiplied by 2 gives us 4. And we subtract that. 4 minus 4 is 0. In that case, nothing left. So we have successful division on the left side as well. And the number we got is 102. So I'm going to rewrite this as 102 divided by this number here, which was the answer, 3. So now we have reduced the big numbers to very small numbers until I see that when I check both sides, I see that this number is 2 and this is 3. One is odd, one is even. So they can't be divided by 2 at least. And of course they can't be divided by 3 as well. And then 4 and 5, and that is beyond the point. That's not possible because these are smaller numbers. So that means now we are going to formally divide these two, just like the way I've shown you before. So I'm going to utilize this side of the screen. I'm going to hopefully draw a straight line. Very good. And I'm going to, just for the sake of clarity, I'm going to rewrite this 102. Oops. 10. Let me rewrite that. 102 divided by 3. This would be written as internationally as 102 divided by 3. And now we can do the proper division operation and say 102 inside, because that's being divided. 3 is dividing it, so 3 would be outside. Now we divide it. So 3, so this first we take this first digit, which is 1. So 1 is definitely smaller than 3. So we just take the next number, which is 0, and it becomes 10, right? And we know that 3, the closest number in 3's table is 9. 3 3's are 9. So that's what I'm going to do. 3 3's are 9. We subtract that. 10 minus 9 is 1. right? So this was the result of a subtraction. We have some remainder. So we can bring down this number without putting a 0 here, because that was its turn anyway. So it became 12. So now 3 in what in 3's table, what is the multiplier or multiple that gives you 12? That is 4. 3 4s are 12, and you subtract them and you get nothing here. So we have a successful division, and we have 34 as the answer to this division, and that actually is our answer, right? And this is what I showed you. This is this operation also ends up with 34, but it shows the student absolutely nothing. And so the method I've shown you, now you know how to work it out. So now I'm going to do the same operation, but I'm going to do a shorter in a bit short way, right? So let's write the question again. Question is, what's the question? Let's see. 81.6 divided by 2.4, right? Very good. So we start by eliminating or getting rid of this decimal, and since both have a single digit on the right side, we can multiply both sides by 10. So we can say 10 multiplied by 81.6, and then we keep the division for now, and then we say 2.4 multiplied by 10. Both of them we have multiplied by 10. So, and the result is, of course, you know from the previous steps I explained, this will simply become 816, and this is just divided by 24, because the decimal point will move right one digit. Okay, 816 divided by 24. So how am I going to solve this here without going through a very long division process? Well, the division process is going to be long, but it's going to be done right here in this area, just in this area. So I'm going to show you how. So 816 divided by 2 can be written as 8. Let me rewrite that. Can be written as 816 divided by 24, right? Good. Now we start dividing. We know both of these numbers from on top and bottom, they are both even numbers because they end with even numbers. So that means they can be divided by 2. So I'm going to just divide both of them by 2 while they are written here, and I'm going to cut it off. I'm going to say cut it off and say 2 4s are 8, and then 1 is not enough, so I put a 0, and then this becomes 16, and I say 2 8s are 16. And then I'm going to cut this out as well and say 2 1s are 2 and 2 2s are 4, right? And then I can just simply write it neatly as 2408 divided by 12. And I see that both of these numbers are even numbers because they end with even numbers. So I can still divide them by 2. So I'm going to cut them out. I'm going to divide both of them by 2. So I'm going to start with 2 12. So 2 6 times is 12. And I'm going to cut it out and say 2 2s are 4. And then the 0 is not enough, so I put a 0 here. and I say 2 4s are 8, right? So this will become 204 divided by 6, and they are still both even numbers. So I'm going to cut them again, or divide both of them by 2 again. So 2 3s are 6 and 2 1s are 2. 0 is not enough, so I just put a 0 here, and I bring in 4, and 2 2s are 4. So this gives me 102 divided by 3. And now I'm going to, I can do the division again right here. I can cut it out, but I want to show you one last step. So it's visually good to do it like this, as I'm going to show you. Remember, the number of steps you show in your working gives you grades, not the final answer. The teacher or the examiner, not teacher, the examiner who examines you wants to see how did you solve a problem, what all steps. So the examiner wants to see your thought process, how you think, how you have approached this problem. So all this working is necessary to show. So the last step, 102 divided by 3, we do it traditionally. We do 3, this is 10, 1 is not enough, so we just take 0 just as it is, and we say 3 3s are 9, 1 left. This is the result of a remainder, so we just bring down 2, and we know that in 3's table we get 12 by multiplying 3 by 4. 3 4s are 12, and we subtract them and we get nothing here. So the answer is 34. That is your answer. And this is, my dear students, although you're not my formal students, but my dear students, this is how you solve a problem, a division problem. Right? So I hope this helps. It's very easy to do it like this, and this is easier method. Remember, there are several ways to solve a problem. The example I showed you earlier, which I took screenshot of, is not clear. It's not easy to understand. It's difficult, and the student is always confused how to use that method. The method I've shown you here is much more easier, and it's intuitive. It helps understand the problem and find the solution. So thank you very much.